Probability video number 4, we are going to look at the probability of two events and possible calculations with this regard. Question A says, use this table which shows the outcomes when two dice are rolled to find out the probability of each event described below. Our first option, on the left hand side we have the first die, and their options are 1 through 6, and then on the top we have the second die and our options are 1 through 6. So what they've done here is they've actually added the scores. So instead of writing 1 1 in our first square, they said 1 plus 1 is 2, and then in the second square they said 1 plus 2 is 3. So instead of showing outcomes, they are showing adding the number of the dice. The first question is saying, what is the probability of you getting a score of 7? So let's have a look. In row number 1, I get a 7 there, another, 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 and another. In total, there are 6 7s possible. So probability of getting number 7 is going to be 6 favorable options over total what? So if you remember correctly, normally what we do is we're going to say 6 down multiplied by 6 across gives me a total of 36 possibilities. This 36 is the number of options in the sample size. So that means my denominator here is 6 out of 36, which then simplifies to 1 out of 6. A probability of getting a score 7 is 1 out of 6. What is the probability of you getting a score 5? Let's count. 1, 2, 3, and 4. The probability of getting 5 is going to be 4 out of 36, which simplifies to a fraction of 1 over 9, or a decimal of 0.11 recurring, approximately 11% chance. This 1 over 6 for the probability of 7 happening is going to be 0.166 recurring, or approximately 16 or 17%, 16.67 or 17% for it, if it's rounded off to 0 decimal places. What is the probability of you having an even number? So I'm going to do that in green, and I'm going to say 1, 2, 3 for my first section, 1, 2, 3 for my second section, right? 1, 2, 3 for the third. Are you noticing a pattern yet? 1, 2, 3 for the fourth, 1, 2, 3 for the fifth, 1, 2, 3 for the sixth. Notice if you go down, it's the same, 1, 2, 3. So in other words, already you notice that this is 3 out of 6 going side to side. If you go up down, it's still 3 out of 6. I'm pointing this out just so that you can see that automatically you can already deduce that it's going to be a half. But let's have a look. We said 3 happens 6 times, which 3 times 6 is 18. The probability of getting an even number is going to be 18 out of 36 in total, which ends up being 1 over 2, or 0.5, which is 50% chance of that happening. What is the probability of you getting something greater than 8? So on dice number 1, 0 possibility. Dice number 2, 0 possibility. 3, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possibilities, or 10 options. So the probability of you getting something that is greater than 8 is going to be 10 out of 36, which then simplifies to, hold on, a fraction of 5 over 18 and a decimal of 0.27 recurring, which approximates to 28% chance of you getting greater than 8. And the last question is saying, what's the probability of getting less than 6? So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The same. So the probability of getting less than 6 is going to be 10 out of 36. 5 out of 18, 0.27 decimal, 7 recurring, approximately 28% chance. What score are you most likely to get when you roll 2 dice? And that is obviously the one with the greatest probability. So if I discard this even, because even is not an option, right? So the even we're not going to look at as an option. The highest score possible is going to be the 7, because probability of you getting 7 is going to be 1 out of 16. That's a specific number. Remember, this is a whole group, this is a whole group, so they don't count, because the yellow one is 9, 10, 11, and 12. The purple one is 2, 3, 4, and 5. So the specific one, that is one specific answer, the highest is going to be the probability of you getting 7, which is 17% probable. The diagram is showing you 2 sets of cards, set A and set B. One card is chosen at random from set A. One card is chosen at random from set B. List all the possible outcomes. Now, remember, there are different visual ways of representing the data. It is entirely up to you how you do it. We could use two-way tables, right? This question A was a two-way table. I want to do something different this time. Let us use a tree. So let's use the tree diagram, and we're going to say event 1 gives me options 1, 2, and 3. Then event 2 gives me the options 2 and 3, 2 and 3, 2 and 3, which means that my outcomes are going to be 1, 2 and 1, 3, 2, 2 and 2, 3, 3, 2 and 3, 3. Now, what have we done? This is our tree diagram, and this is the outcome of the tree diagram. But if you did this alone, this would also be known as systematic listing by itself. And then again, obviously, you could also draw a table where you could have 3 options, 1, 2, 3 for A, and over here you have 2 options, 2 and 3 for B. And all of those are different ways of representing the same information. Now, the next question that we are looking at is saying we've done A1, which we've listed the outcomes. The 2 numbers that are added together, what is the probability of getting a 5, and what is the probability of getting a not 5? So let's start by adding the numbers. 1 plus 2 is 3, 3 plus 1 is 4, 2 plus 2 is 4, then we have 5, 5 and 6. So the question number 2 over here is saying, what's the probability of getting 5? There are 2 options here. So the probability of getting 5 as a total when it's added together is going to be 1, 2. 2 chances of it happening out of 1, 2, 3, 4, 5, 6. 2 out of 6, or 1 out of 3, or 0.33 recurring, or 33% approximately. Question number 3 over here is saying, what's the probability of getting not 5? So again, there's different ways of doing this. We could do the same thing we did here and count the not 5s, or we can do the other equation that we've been doing, and we can say probability of how shall we write this? 5 with a line. So not 5 is going to be 1 minus the probability of 5, which is 1 minus 1 over 3. So the probability of getting not 5 is going to be 2 over 3, or 66%, 67%. A new card is added to set B. It is now the number 5. One card is chosen at random from set A and one card from set B. How many possible outcomes are there now? So what happens now is we are going to add an additional branch. So if I go back to my previous drawing, I would add an additional branch on each one, right? Making it 3 branches instead of 2 on my second card, drawing of the second card. But if I wanted to do this arithmetically, just using calculations, I would say A, the number of options in A, multiplied by the number of options in B, will give me the total number of options in the sample size. So there are 3 options in A, and there are 3 options in B because we have now added a new card, meaning there should be 9 total. Notice over here when we had 3 times 2, we had 6 total, and that was our denominator there. So to answer question number BI, I'm saying that there are 6 possible outcomes. Question 2 is saying, explain why adding a new card does not change the number of outcomes for the total being 5. Notice that the number that is added on the card is 5. So 5 plus 0 is the only possibility for us to get a total of 5, and A does not give us an option of 0. So whatever the outcome is now, it's going to be greater than 5. Question number 3 says, explain why adding a new card does change the probability of getting a total of 5. Explain why adding a new card does not change the number of outcomes that have a total of 5. Explain why adding a new card does change the probability. Okay, because the probability of it happening, remember we're saying probability is number of events. So we're looking at number of times I get 5 over the number of the sample size. Now the reason question number 2 over here is looking at the number of events for getting 5. That does not change, but the probability changes because the denominator changes. It is now, we have 2 out of 9 instead of 2 out of 6. So the probability changes because the number in the sample, or the total possible answers, increases because of the new card. All right, folks, please like and subscribe, and go ahead and ask your questions. I will see you in class. Have a great day. Bye-bye.